Hi again, Mr. Fitry here, bringing you Lesson 3 of Unit 3. This one is called The Theory of Plate Tectonics, okay? Building on what we have learned so far. All right? Again, we just have one objective, and that objective is what is the theory of plate tectonics? Okay? Again, we've got a map here with our continents, you see, but also you got some black lines running through the continents, but in particular below the ocean floor. Okay, those are the plates of the Earth. You see, there's quite a few. We have 7 continents, but we've got quite a few more plates. So we're going to look at these here. Here we've got our vocabulary. Okay, the first one is diverge. This is separate or go in different directions. Next is converge, which is meet at a point. Also, they come together and meet at a point. Okay. Transform, make a thorough or dramatic change. Okay, think of a caterpillar. When a caterpillar becomes a butterfly, it has transformed. It has made a thorough and dramatic change. Okay. A boundary, a line that marks the limits of an area. We talked about that last time. And a fault, okay, is a break in the Earth's crust where rocks slide past each other. Okay? The picture from the last slide of the black lines under the ocean floor and through some of the continents, those are the faults, which we're going to look at today. So to begin here, the plates of the Earth. Okay? These are pieces of the Earth's crust, all right, which are separated by cracks. Now, these plates are in slow, constant motion, and like we've talked about before, they are driven by the convection currents in the mantle. Okay, and we call this movement plate tectonics. The picture below here, you see the plates of the Earth again. Okay, the Eurasian plate, the Pacific plate, the African plate, the Indo-Australian plate, the Philippine plate, and you can see where they're all moving. Some are moving apart, some are moving together, some are sliding past each other. So we're going to look at those movements today. But before we do, we have to understand that the convection currents in the mantle are a strong enough force to move the plates. So these convection currents can move continents, so they're extraordinarily strong. Okay, but even though they're really strong, the plates only move about 1 to 12 centimeters per year. So as we know, it has taken hundreds of millions of years for the plates and the continents, essentially, to get to where they are now. Okay? Now, as the plates move, they change Earth's surface. They produce earthquakes, they create volcanoes, they form mountain ranges, and deep ocean trenches. Now, as we go forward in the class here, we will actually look at each of these specifically, okay? We're going to look to understand what happens with a volcano, what happens in an earthquake, how do mountains form, etc. Okay? Now, these plates, okay, they meet at boundaries called faults, and there are 3 types of boundaries. A divergent boundary, where plates move apart or diverge. A convergent boundary, where plates come together or converge. And transform boundary, where plates move past each other in opposite directions. So let's look at divergent boundaries a bit closer. So again, a divergent boundary, this is where plates move apart or diverge. Now, most divergent boundaries occur underwater at mid-ocean ridges, all right, where the convection currents move the oceanic plates, allowing that hot magma, hot rock to rise up, forming new oceanic crust. But there are some that occur above water on land. But we don't call these mid-ocean ridges, obviously. We call them rift valleys. And you see the picture on the bottom right of the East African Rift Valley. Now, at these boundaries, and this is important, rock is created. Okay? New rock, new land is created here. Next are convergent boundaries. This is where plates come together or converge. So you have to think, if plates the size of continents, when they come together, something has to happen, right? They're pretty big, it's not like they can step aside. Well, something does happen. The density of the plates determines which one, and if one, sinks. If they do sink, it is always the denser one that does. Okay, so the denser plate will sink. Now, what does this look like? Well, oceanic crust is more dense than continental crust. All right, so when an oceanic plate and a continental plate converge, the oceanic plate will subduct under the continental plate, or under the continental crust, while at the same time pushing the continental plate up. And when that happens, they form mountains and volcanoes. Okay, this formed the Andes in South America, as the Pacific plate collided or converged with the South American plate. Now, if two oceanic plates collide, because of the cooling effect on the plates, it causes the plates to melt. Okay, because obviously the ocean is cooler than the crust or the mantle. All right, so it cools the plates and causes the plates to melt. This allows magma to rise up, melt the plates, and form volcanoes. Finally, if two continental plates collide, because their density is almost equal, it causes each plate to push up, forming mountain ranges. Okay, this is how the Himalayas in Asia formed, as the Indian plate collided with the Eurasian plate. Okay. Now, at convergent boundaries, rock is destroyed, primarily when one subducts under the other. Okay, so here we see a couple convergent boundaries, okay, where the first one on top there is an oceanic plate colliding with a continental plate. The oceanic plate, being more dense, subducts under the continental plate, forming mountains and volcanoes. The middle one, two oceanic plates. The cooling effect of the ocean causes the plates to melt, forming volcanoes. The last one at the bottom, two continental plates cause each other to push up, forming mountains. All right. Now, just to add a little perspective, let's say. All right, on the top left corner of the mountain, that's the Himalayas, okay, two continental plates colliding. Now, the bottom picture here, those are two volcanoes in Guatemala, okay? And the map to the right is a map of Central America. Now, if you look, you see the little yellow triangles. Those are each volcanoes that are active or dormant, okay, in Central America. So that means they could erupt or have erupted recently. Now, all of Central America and these volcanoes and mountain ranges were formed by two oceanic plates colliding, melting, and forming volcanoes, which created a landmass over, of course, millions of years. Finally, transform boundaries. Transform boundaries are when plates move past each other in opposite directions, okay? That's important to note. They're moving past each other in opposite directions. Now, of course, we're talking about rock, okay? And because plates are made of rock, of course, the sides of the plates are jagged and rocky, and they often stick together. They can lock in place. And even though they're locked in place, the movement of the Earth continues, increasing the pressure behind the rock. When the rock unlocks, okay, when it moves or shifts, earthquakes occur. Okay? So when that rock that has built up tension after being locked in place, it creates an earthquake. Now, importantly, at these boundaries, crust is neither created or destroyed. Okay? At divergent boundaries, crust is created. At convergent boundaries, it is destroyed. One of the most famous, let's say, transform boundaries is in California, in the United States, and that's called the San Andreas Fault. You see the map on the top right of the fault runs right through California, causes a lot of earthquakes, okay? You also see the picture of the fault line below, where you can actually see the crack in the earth. Okay, now to finish up here, okay? What is the theory of plate tectonics? Well, again, we have three boundaries that have caused movement on Earth's surface, okay? Among the plates, which you see in the map there. Okay, we've got convergent boundaries, boundaries that come together, divergent boundaries, plates or boundaries where plates move apart, and transform boundaries, where plates move past each other in opposite directions. So we will continue to build upon these because there's other ways to look at these boundaries, which we'll talk about later. All right. So again, as always, if you have questions or anything, feel free to reach out to me. I will also likely include a video or two to perhaps make this a little bit more clearer, maybe a bit more interactive. All right. Thanks so much.